So today we are going to learn, this week actually, we are going to learn two important concepts. First one is so-called array, which is like a collections of variables. So far we learned how to declare individual variables. So we create a memory block, just hold one piece of data. For example, if I want to have some kind of like a salary to be stored somewhere, or declare a double variable to hold the salary. If I want to have like age, the integer, then I will declare integer variable to hold that number. Okay, so all the times we declare just a variable, a memory block to hold one single piece of data, right? But often we found that we need like a memory location, a memory block to hold many pieces of data of the same kind. For example, if I want to declare a variable to hold entire company's employee salary, so we have like 1,000 employees, everybody has a salary, right? So how can we do that? So it will be ineffective if we declare 1,000 variables, one for each employee. Does that make sense? So employee 1, employee 2, 1,000. That's too many variables to declare, right? So it will be more effective if I just declare one variable, and with sub-blocks, each block will hold one employee's salary. Okay, so that is called array. We're going to talk about that. And when we introduce array or collection like a list array, then we have to talk about how we are going to process those kind of data, right? So a lot of times the data will be repeated. The code we are going to process will be repeatedly. So for example, we need to write a code handle first employee, second employee, third employee, 1,000th employee, so all the employees. So the code we are going to write for each employee are the same, right? So we are not going to write 1,000 lines of code to process each employee. So instead, we want to have something to control that. The code will be just processed. We just need to write it once, and then the code can be repeated 1,000 times, something like that. Okay, so that would be something called a loop. Okay, before that, we still need to get a concept, what is called a global variable reviewed. I want to have one more example to show you that. So for that purpose, I am going to create a small project to do that. So let me open up my node first. I'm going to follow this node. So this is a global variable, local variable stuff, okay? So let me just go to, let's share my screen first. So let's create a new Visual Studio project. Okay, and then let's just say I want to create a new project. And then the Windows apps, Windows Forms. Okay, follow me. Okay, put your hands on, create a project. And then let's say I want to create the one called, I think we did my fourth example. So let's just do my fifth example. And then we're going to save that to desktop also. Okay, so just make sure you save to your desktop. I'm going to save to desktop. I will put into 315 school. Okay, I did a third example, not a fifth example actually. So let's just put it inside here. Okay, so my maybe just fourth example instead of fifth example. Okay. All right, and then anything else? Nothing, right? So basically, this is C# and Windows Forms as a template. I'm going to create a new project, press an OK. All right, and then here, let's just do something pretty simple. So now let's just say I want to create one text box to show the numbers. Okay, let's start with a text box. Okay, so let's just say this text box is going to hold the count. So txt count. Okay. And then I'm going to create two buttons. The first button is record when a car, let's say this is going to be used by garage to record the number of cars in the garage. So the first button will be just say when your car is entered, then you add 1. So I will change this to enter as text. Then the name is btn enter. Okay, then do the same thing for another box, just say leave. So when a car leave, I will reduce the count. And this is btn leave. Okay. And then just give text as leave. Okay. So let's make things look like better. Just put a label in front of it also. You see the label is cars. You see count. The total number of cars in the garage. Okay, count. All right. Now let's see what we're trying to do. So basically, it's a very simple thing. So I want to say when I press this enter, a new car come in, then the count will increase by 1. And then if I press leave, then the count will reduce by 1. So just assuming that somebody sitting at the door, pressing these buttons. When a new car comes, press this button. When the car leaves, press this button. So anytime you will know how many cars are in the garage. All right. So now let's just say how can we do that, right? So basically, if I'm going to do something like say using local variable stuff, you will say that it's not going to work. So let's just go to enter, double click, enter. So first of all, I need to have a variable to hold a count, right? So integer count. All right. Integer count. All right. Okay. Next, I can initialize a count equal to 0 first. All right. And then every time when the car comes in, so when they enter, then the count should increase by 1, right? So count increase by 1. So what does it mean? So basically, I need to get how many cars already in the garage. So how many cars in the garage? That is inside txt count .txt, right? So you need to get that. And then, of course, you need to conversion. So same thing happen. So to convert to integer 32. So assuming the number of cars is integer. So you need to convert that. Okay. And then you would just increase by count, increase. So this is you can just say increase by 1, right? So this is increase by 1. Okay. All right. And then this is equivalent. If you do this one is equivalent to this. You can just say count plus plus. That's the same thing. Okay. So if I just comment this line out, okay, comment this line. That is equivalent to this. Equivalent to say count plus plus. So that is the same thing like the increase by 1. Okay. All right. So sometimes we write a code, just trying to not writing too much code, right? Trying to do same thing with less code. So this is the same thing as the previous one. Okay. Now after the variable is increased, now let's say I want to put the variable back on the text box. So you will do that txt count again, .text equals to count, right? Okay. And then of course you need to do conversion. So because the right hand side is a number, so you're going to convert to string. Convert to string. Okay. Now if you're going to do what a standard approach, standard just like what we did before. You declare variable and then initialize here. We initialize 2 different ways. You can initialize to 0, initialize to whatever. So I think it probably is better make more sense to initialize to whatever is on the form. but then initially that is 0 though. That is initially that's 0. So we are that's empty, right? So if there's no car in there, it's going to be empty there, right? So that is going to be a problem there. So let's just say if I initialize to 0 first, okay? Initialize to 0, and then I will do count plus plus. Okay, let's do that. Okay, I will do that. Okay, and then we count plus plus, and then we initialize. Okay, now let's see what's going to happen. Okay, so this is so we initialize to 0, and then when I do increase by 1, then I will just do that. Okay, so now let's run it, and we see that it's going to be a problem. Okay. Okay, so initialize to 0, press enter. Now I get a 1, still 1, still 1. Can somebody tell me why it's still 1? Because every time you press this button, this is change back to 0, and then increase by 1. Okay, so this will be keep on doing just 1. You're not going to have more cars, more than 1. Does it make sense? Okay, so it would be better to do something like this. Okay, let's just say if I initialize to what is inside the car, then let's see what's going to happen. Okay, run that. Now at this point, if you press enter button, you're going to have a code crashed. You're going to have a code crashed because there's nothing in there. So in this case, suppose I put 0 in there, then it will start to work. Okay, 1, 2, 3, that will work. Okay, that will work. Then you will start to increase. But if you have nothing in there, start with nothing, then you press enter, then your code is going to crash because you know that this conversion will not work. This line, because you convert something which has nothing, has no data in there, you're trying to convert that into integer, that will not work. Okay, so now let me do the opposite one. So suppose I do the opposite one to leave 1. Okay, let's do that one. So then I'm going to say integer count again. And then say count equals to txt count.text. Okay, and then we're going to do conversion also to integer. And then this time we are going to decrease by 1. So we'll do the count minus minus. That's how just say count equals the count of minus 1. Okay, count of minus minus. Make sense? And now let's just report the result. Say count.text equals to count. Okay, and then of course we need to convert this into text. So convert to string. So because you need to convert to whatever on the left-hand side type. Okay, to match the left-hand side type. The left-hand side is text, is a string. So you need to convert to string. Okay. Now if I do that, then you will see that you're going to have the same problem. So that we'll have to put 0 start with and then enter. Okay. And then say leave. That will be okay. Okay. Leave. That start work. Okay. Does that make sense? So this is 8, and now this variable is, so whatever count you're going to declare, then that count is going to get data from the text box. Okay. So in a sense, in this case, we are using a text box to get like a total number of to get a total count, and then when you declare a new variable count. So this time, so you see that the count, they both use the same name. That's okay, right? Basically, this count will be only available to this one, to the code inside here, this code module, and this count will be only available to this inside here. Okay. Now, essentially, we are trying to share the same variable count. Okay, so now let's try to do declare global variables case. Okay, so what I'm going to do is comment this line out and comment this line out. Okay, and then we're going to declare a variable which is a global variable. Global variable is outside of this code module. So if you look at here, this is the project, and this is the class, and this is a function, this is function. So anything outside the function you declare, then this is, say, integer, say, count, you can do that. Okay? All right, so now, if you declare variable outside here, can you also initialize the variables, for example, equal to 0 here? In theory, you cannot. Only in the special cases when you have like a primitive data, like integer, double, all that, you can just initialize the something. However, general place to initialize those variables, so-called global variables, is inside the constructor. So remember, we are getting to the inside of a constructor. So this is a constructor, form1, which have the same name as the class, right? So we can do that. We can initialize in here. So for example, we can say count equal to 0. Start with 0. I think we did that last class, did we? When we guess a number, like random number, so we can put those guess number in here too, right? So this is place to initialize. So let me just write here. Place to initialize global variables. Okay, so this is global variable. This is a global variable. Okay, so any place, anything outside the function, the variable you declared outside is going to be that. And just remember that for global variables, you only declare it, but you do not process it, you do not assign values to it, you do not assign initialize inside here. You cannot write code in here. Okay, only code you can write is just global variable here. Okay, and also make sure you understand there is another concept called the public variable. So for example, if I make this to be public, that's how I can do that. But that is not the same as global variable. Public variable just means this variable is going to be, the data for count is going to be visible to other code besides this class. So here, the code, the count is only available to the class, to the informs one. But if you make it public, then this count can be available to other classes, other forms, other places. So that's what public means. So there you say the public, there's private. Okay, so in general, you really don't make data to be public. You have to make this private. So we are going to get more in the future, but not now. Okay, so for now, so just understand that public variable is not the same as global. Public variable is not the same as global variable. Global variable just means that the variable is declared outside of all functions. Okay, but it's not public. Okay. Does everybody understand? So let me try to say, put here, public means accessible to other forms or classes. Okay, public just means accessible to other forms. So here we have form 1, right? So you may have form 2, form 3. If you want the data to be accessible to those, then you change. You can make this data to be public, but it's not a good practice, right? All right, so now let's say, I'll come back to the problem here. So now we declare that variable, and then when the form starts up, initialize to 0, okay? And now let's say, what do we do? Okay, so now we can just do, so first of all, we can put data on the form. Put data on the form first. So let's just say txt. Oh, we can do that here. We can do that here. So after the data is initialized, I say txt count text equals to count. So we'll show that count right away. Okay. So of course you need to convert to string. So this constructor not only initialize the count variable, but also initialize the text box. So text box will be showing 0 also. Okay. And then after that, then this code will be all of a sudden will be working, and you just need to just do what? Just say count. I will do this one. I will not need this anymore. I think. So I will just simply say if I press enter, then the count increases by 1. If I press leave, I will decrease the count by 1. Okay, and then I will just show the variable count on the text box. So I will just simplify everything, the code into 2 lines of code. Okay, so what we have achieved, instead of using local variable count, because we are sharing the same count in both buttons, right? So let's declare that as a global variable. Okay, so that is the first purpose. Secondly, for the global variable, you have to initialize inside constructor, inside the constructor. Okay, and then this is the one thing that we did. And then after we have the count, we put that data into the form. And after that, we press enter button, just say count increase by 1 and show the new count. And then count leave, I will just decrease count and then show the count, show the new count. Okay, so now this is working perfectly as desired. So enter, leave, enter, leave. Okay, so because this case we have 2 buttons. Both buttons will share the same count. So when you the job was simple. Just when you do that, the count increases by 1 and then show the new count. When you press this button, the count decreases by 1 and then show the new count. Okay, but the count is declared outside of those buttons. This button leave, this button count. They don't have a variable called count. Okay, so instead the count was outside, declared outside, declared globally. Okay, and then initialize inside the constructor. All right. So this example demonstrates how we are formally how we're going to do global variables. Declare outside, first thing. Second, initialize using constructors. Okay, and then the variable will be shared by all the buttons, by all the functions we're going to write. So here we have only 2 buttons. Okay. All right, so that is the concept of a global variable. I just want to have another time to review it. And then after that, let me see. So make sure you know how to use if else, there's no then actually, if else, okay? And the Visual Basic have if then, else, if then, else, something like that. But this is C#, there's no then, just else if else. Make sure you understand that. Global variables, we talk about that, okay? And now let's see. Let's do this. We already did that. I think this is what we're talking about. So now let's talk about arrays. Okay, arrays. I explained to you that array is to use to declare a memory block with sub blocks to hold same pieces of data. Okay, so this is generally how we do it. Okay, so now let me open up whiteboard to show how we do that first. Okay, so I'm going to come back to the project, close that. Okay, so I'm going to use a whiteboard to do that. This is a different one, so let's create another one. Okay. First, to use array, so just imagine that you are going to create a memory block. A memory block just like usual. So you can say this is this memory block to hold, say, salaries. Okay. So let's say I want to hold salaries for the entire company, which has like 1,000 employees. 1,000 employees. Okay. So instead of declaring 1,000 salary variables, salary 1, salary 2, salary 1,000, that's too time consuming, right? So I'm going to declare just one block, one memory block. That's called salaries. And that block will be divided into many sub blocks. How many? Starting from 0, actually. So this is another thing with C#. Okay, with C#, Java, C++, those are those programming languages. When you start to count, you always count from 0. start, this is the base, beginning count, base count. Okay, and then the next number is 1, and then 2, and then dot. So what is last number? Since we want 1,000 blocks, so the last number should be 999. Is that right? So in total you have 1,000. Okay, and then put data into the issue of the subblocks. Okay, so this is how this is array. This is called array. Okay, and the data you're going to put inside is going to be salaries. Salaries have decimal numbers, right? So what kind of data is that? So the data is going to be double. So you're going to say double. Okay. So first of all, you specify the type, and then you specify your square bracket to tell that this is going to be an array. Okay, it's not just regular double. So if you do regular variable, say double salary. Okay, remember in that case, the computer will just simply create one memory block called salary. Right? So this is double. And now we are going to do those, just there's nothing inside, just square brackets, nothing inside. Okay, so double and square bracket. So that indicates that you are going to create not just one single block. You are going to create many blocks of same kind of data, which is double. Okay, and then you give a name, say salaries. Okay, and then you say equals to new. Okay, you remember this one, right? Okay, and then you tell how many double you want. So then you say double, and then square bracket, and say I want 1,000 of that. And that is the statement, that is the whole statement to create this memory block with 1,000 subblocks. With 1,000 subblocks. Okay? Now, after you declare this memory with subblocks, how am I going to put data into each subblocks? I'm going to, for example, put 5,000 here, 1,000 here, 2,000 here. To do that, you are going to use index, okay? So this is how you reference to individual items. You say salaries, 0, that means the first subblock, equals to, say, 5,000, semicolon. Okay? And say, let's do the same thing. Let's say I want to put 1,000 here. So this is the 5,000, right? Then I want to put 1,000 in here. So to do that, you will say salaries 1, this index 1 equals to 1,000. Okay? Then do the same thing. Salaries. 2. That means the third subblock is going to be 3,000. Okay? And then, of course, you're trying to initialize everyone, then you need to initialize last one. The last one, you will say 4,000. Then you'll probably write a code like this. So you'll see that you're going to write 1,000 lines of code. That is very tedious, right? Then this is 999. The last one equals to, say, 4,000. So that's how you initialize each individual subblocks after you declare that. Okay. Now, this is like a what? So you basically initialize once and then initialize, you declare once and then initialize each one separately. This is how you do it. Equivalently, equivalently, you can do this one. You just do once, equivalent. You can do this one. This is how you do it. You can just say double, still square bracket, and then you say salaries. Okay, and then you say equals to new, okay, double, okay, and then put a square bracket here, and you can put 1,000, I think, and then you say put data in here. So put a curly brackets, okay, and then the first one you want to be what, 5,000. Second one is 1,000. Third one is 3,000. Continue. You can use the data, put data inside the square bracket, separated by comma, and that can be used to initialize the whole thing. So basically, all the statement as did from here to here can be done by just one statement. It's equivalent to this one, just once. Okay, so that is another way to do it. So let's use both approaches to create the film. Okay, so this time let's say I want to create a memory block to hold three names. Okay, so name is a text, so it's going to be string. Okay, and then your square bracket. Don't forget that. And then say names, and then equal to new, okay, and then say string. I said three names, right? So you can say three here, okay? And then you can put individual names inside, so names 0 equals to, this is text, so let's say John, semicolon, and names 1 equals to, say, Lisa, and names 2 equals to, say, Smith. Okay, double quotes. So essentially this 4 lines of code will create a memory block. The memory block will call the names. The whole thing is called names. Okay, it's going to have 3 subblocks with index 0, 1, and 2, respectively. And then you put the data inside the subblocks. So this is John, and this is Lisa, and this is Smith. So essentially, you are writing the code, ask the computer to create a memory block like this. Okay. Now equivalently, you can do this one. You can just say string, square bracket, and names. Okay, equals to new, and then say string, and then say 3 here, and then you can put the names just right besides that. Say this is John, comma. So I'm going to continue like this way. Lisa and Smith. Like that. Curly brackets. And then semicolon. So in this case, you are initializing this John to the first one, Lisa to the second one, and Smith to the third one. Like that. Okay. Now you can also, is that enough for this simple data? You can also initialize, you can create also something like a 2-dimensional blocks. 2-dimensional blocks. So let's say I want to create create like a table, okay? So I want to create a table like this. Okay. So I want to put data like a 1, 3, 4, and then 5, 2, 1, something like that. Okay. So let's say I want to create a memory block with 6 sub-blocks, but this time the sub-blocks are arranged in a way that it has rows and columns. So this is row 0 and row 1. And this is column 0, there's a column 1, and there's column 2, right? Okay, so if you're going to do something like this, something like that, this is what you're going to do. So you're going to do, so these are all integers, right? So I'm going to say integer, square bracket, and this time we have about 2 dimensions, so we put a comma in the middle. Comma in the middle. Okay, so let's just say this is my integer, so maybe what is it called? Let's just say, just trying to give a name for this memory block. So let's just call this as values, okay? Values. Okay, and this values is going to be 2-dimensional, so you're going to say integer, okay, and then square bracket, and then you specify how many rows? 2 rows. How many columns? 3 columns. That is how we declare 2-dimensional arrays. Okay, and after that, we are ready. We can initialize each individual ones by using the column index or row index. So we can say values. So let's just do alignment. So let's say values. So remember that is the entire memory block. This entire memory block called values. Okay, it has 6 sub-blocks, but they are arranged in the rows and the columns. Okay, so values 0, 0. So 0 row, 0 column, so that's 1. So that is equal to 1, for example. And then do the same thing, values. Okay, and then 0 row and column 1, so that equals to 3. Values 0 row, column 2, column 3, actually this is last column, that equals to 4. Okay, remember the base count is 0. And let's do the same thing for the second row, so values 1, 0, column 0, so that would be this number. Second row, fourth column, that's 5. Semicolon always, okay? And the values 1 and 1, that's equals to this 2. Okay, finally, values 1 and 2, that will be equals to this one. Equals to this one. Okay. So now all these lines of code is equivalent to create a memory block like that with data initialized. Okay. Now, if you want to use the equivalent approach, just say I want to initialize at the same time instead of using this, then in this case, you're going to initialize it as you're going to do this something similar. Let's say equivalent. You're going to take integer, square bracket, comma. You still need that, okay? And then say values. Okay, and then equal to new, and then say integer. Say 2, 3, right? And then you're going to put curly brackets and the curly brackets, okay? First of all. And then inside, then you're going to use curly brackets for each row. Okay, so you're going to use, the first row is going to be, let's look at the first row. So first row is going to be 1, 3, 4, right? So you can put 1, 3, 4, curly brackets, and then comma, and then you put a second row, 5, 2, 1, and then curly brackets. So you have only 2 rows. So you can use this way to initialize this table like what I did individually. So this is equivalent. Equivalent. So this is how we do that. Okay. Now let me see whether there's any questions at this point. So I have an example which has 3 by 4, so I don't need that. Okay. All right, any questions? Okay. Now, when you use array, there is a restriction. So before you create this memory block, you should know how many sub-blocks you need. So for example, in the first case, for salary case, I know that I need 1,000. Okay, so you need to have fixed number of 1,000. Okay, so if you, for example, in some cases, I don't know how many salaries, how many sub-blocks I need, then you cannot use array. So in that case, what you can use, there's another structure called the list. List will allow you to do that. So I'm going to just put that down, but not going to do that here. So alternative to array is list, which can have undetermined number of sub-blocks. Okay. So that is one of the property regarding the array. So the size, the number of size, the size is going to be fixed, and the size is determined by the constructor. So basically, say for example 2, 3, that means you need to have a array like 6 blocks, right? And then if the size is like a 3 in this case, that means you have 3 sub-blocks, okay? And 1,000. So basically size is determined by the constructor, okay? And then the size actually can be accessed. So if you want to say how many, so if inside the code, you want to say how many numbers inside the values, and this is by using a property called, so for example, values.length. So that will tell you how many in total, okay? How many variables, how many subcells. So for example, if you apply that to names.count, names.length, names.length, in this case will be equal to 3, names.length. So that property will tell you how many sub-blocks in the array, okay? So we already did that. So each cell in the block is referenced by the name of the array and also an index, unique index starting from 0. All right. Now that we basically handle that. Say basically we can declare a variable which holds many pieces of data of same kind. Okay, instead of creating many variables. Okay, so that's an improvement. But now we understand that, so sometimes like this is too hard to write a code. Say for example, I want to initialize these variables to all to 0. So we have to write salary 0 equals 0, salary 1 equals 0, salary 2 equals 0, salary 999 equals 0. So basically you're writing the code just indefinitely, just like 1,000 times. For the same kind of code, you write 1,000 times, right? So to solve that problem, to handle that problem, we need another concept called loop. Okay, just remind 6:40, right? So our class 6:40, so we should have 40 minutes. So now let's come the concept of loop. So loop basically, we are going to have like a for loop for each loop and a while loop to be covered. And the loops are used to so basically loops are used whenever you need to execute the same set of instructions repeatedly. That's what's going to do. Okay, let me just give you an example here. Suppose I want to create an array of 5,000 integers and initialize all to 0. Okay, so first thing is easy. Just declare a variable to hold 5,000 numbers. Okay, so let's go all the way to here. All 0. Let's say integers. Let's say integer. Square bracket, and then just say ints, okay? Okay, that's the name of variable, name of block, equals to new and the integer, and then you say that is 5,000. That is even more difficult, right? So that's not the most difficult because sometimes you're dealing with millions of records of data. So this is not that difficult. So here we are dealing with that we have a sub-block, a memory block with 5,000 sub-blocks. So this is 0, and this is 1, and then this last one is should be what? 4,999, right? So in total length is 5,000, right? And now this job is simple. Our job is actually simple, but actually it's not easy to do it. So we want to initialize all to 0, right? We should initialize to all zeros, okay? So in that case, you're essentially doing something like this. So integer int 1, 0, okay, start with 0, that's 0. And then is 1, then is equals to 0 also. And int 2, that's also equal to 0. And then blah, blah, blah. So you're going to write 5,000 times. Isn't that boring? Tedious is boring. It's not tedious. It's just boring, right? It's just not fun to do that. So what we could do instead of this, so let's say we skip. You cannot write a code like this, right? This is just for lecture. You cannot write a code inside C# like this, right? So you have to write every line, clearly. So this is like integer 3, integer 4, whatever they are, ins. Okay. So integer, the last one you're going to write is 4,999. Okay, equal to 0. So you're going to write everyone explicitly. So this is not a math. This is a programming. Okay, it's programming. Program, not math. Okay, so if you do math, you probably can do something like that, right? So people understand that this is going to be skipped or ignored. But when you write a code, every line of the code must be explicit. Okay. Now, how can we do that? So basically, if you look at here, we are writing same line of code, same thing, same code, except that this index is changed. Okay. So what we could do is just for loop. Okay. Now this for loop will specify. So the syntax is this for. Okay. The syntax. Okay. And then you declare a variable like the step count. So let's just say integer step count. You can see this I equal to 0, starting from 0. Okay, that's the first one. So basically this part is initial step. The first step, initial step. So you're going to write a loop to perform many steps of instruction of executions. So this is the first step. First step, you set I equal to 0, and then let's say the last step is going to be I less than or equal to 4,999. So that will be last step. Okay, so that is terminal step, final step. Okay. And then you need to tell how you're going to reach from this first step to last step. From the first step to last step. So basically you're going to do, say, first step is 0, then the next step is 1, then 2, then 3, right? So every time you just increase by 1, right? So in that case, you can say I equals to I plus 1, or just simply say I plus plus. Remember that, right? So this is, let's say, increment or decrement. So just tell how you're going to reach from this initial step to last step. Okay. So this could be I plus plus. So that is just means that you're going to do each step increase by 1, or just I minus minus. That means I equals to I minus 1. So you decrease by 1. Of course, if you do I minus 1, then this will not work. You cannot from 0 to decrease by 1 to reach 4,999. But if you switch around, so make I equals to 4,999 first, and then this here, so make I equal greater than 0, then this I minus minus should work, okay? So here, basically just control how you're going to change this step count, okay? So step count can be increased by 1, you can also increase by 2, or increase by 3, or increase by some other numbers, okay? So here, we are supposed to just do 1, all right? So now let's parentheses, close that, okay? And then you put a curly brackets and a curly brackets. So then you write a code in here, and that will tell how this, in each step, the code will be executed. Okay, so in our code, this is going to be simple. So we are going to just write one simple line of code, which is integer I equal to 0. So this is just one simple line of code. So basically, this is equivalent to 5,000 lines of code you're going to write without it. You see that? So if you're going to write integer 0 equals 0, 1 equals 0, 2 equals 0, so you're going to write 5,000 times, right? So writing 5,000.
Code again.
Beg your pardon?
Could you show the code for declaring the loops again, real quick?
Oh, decline to you talk about decrement?
Yeah, just that right there.
Okay, the decrement. The decrement is I minus minus, and this is equivalent to I equals to I minus 1. Okay, either one, okay? Either one of this. So there's no semicolon. Well, inside here, you should not have semicolon. So inside here, you have only semicolon after the first two. So this is one statement. Basically, you declare a variable and initialize to first step. And then you declare step variable, and then this is the final step indicating that, and this is the final check. Say when you reach to this step, the loop will stop working. The loop will be broken. So you don't. So I will not increase again, and then this code will not exceed to 4,999. So this is you can just consider this is just like a final check. And if this is reached, then this loop will stop. This loop will be broken. The loop will stop working. Okay, and then your control will go to end of the loop. So whatever code in here will be executed. Okay, so that is the step to stop processing the loop. Make sense? Good. Next, let's do one more thing using loop, but this time I want to do something a little bit more interesting. Say, suppose I want to declare, I want to have a memory block to hold 500 random numbers. 500 random numbers. Okay, so first of all, let's just say the numbers are integers, okay? So integer, square bracket, and then let's just say random numbers, okay? Random numbers equals to new, and then say integer, square bracket, and then we say 500, okay? So we declare variable, declare array first, and now let's say how can we put values into these random numbers? Okay, we have 500 of them. Of course, to do that, we need a random number generator. So let's say do random. Okay, and then say my generator. Okay, equals to new random. All right, so usually we have to start working with each individually. We'll do something like this, random numbers, 0 equals to my generator. Dot next, let's say I want to start from 1 to 6, okay? 1 to 6, so generate a number between 1 to 6. So that will be the first one. And then we do it again, say random numbers 1, that will be equals to my generator. Dot next, 1, 2, 6. Okay, and now out of 500, you have to write 500 of this. So this will have to continue, dot, dot, dot. You have to write 500 lines of code like that. So that is boring, right? So it's not fun to do that. So let's see, well, how can we use code? So basically, we use loop. So you look at here, clearly we just need to like a for loop to control this index. And everything else is the same, right? This is the same, this is the same. So we only need to change this index. So this is the point. This is the perfect place to use a for loop, because the for loop allows you to basically have like a count, the step count, and that step count can be used as index. Okay, and then you can change that index every step. Okay, and then the code basically just depends on the index only and nothing else, right? So that will be perfectly to use the code. So we can just, instead of those 500 lines of code, we're going to do for loop. And then declare that count variables. Let's say integer I equal to 0 first. And then say I less than or equal to 499. Okay, we can do the opposite way. Let's just do the opposite way. So I'm not just saying that, suggesting that you always have to do starting from, always have to start from like a bigger number, a small number. Let's just do this. We're going to do the opposite, and then do declining. Okay, so let's do the opposite. So let's say integer I can start with 499. Okay, and then every time I decrease by 1, and then until that I reach to greater than equal to 0. Okay, greater than equal to 0. That's the final step. So you cannot have I is less than 0. If you have I less than 0, then this loop will be broken. And then I will do I minus minus. Okay, minus minus. And then I'll put it inside the code. I'll put inside the curly brackets, just one line code. That is random numbers. This index I equals to my generator dot next, this is parentheses 1 to 6. So there's one simple line code. We're replacing those 500 lines of code. Okay, so this is how we can use a for loop to process this. Okay, now along the same line, let me say one time. I think I have a little bit more time. So next, let's just do one more example using for loop. Okay, using for loop, but this time let's do it in computer. And what I want to do is I want to do this. I want to do 1 plus 2. Let's do something simple first. 3 over 4 plus all the way to 50,000. Okay, 50,000. You understand that this is not, you cannot do it by hand, right? Okay, and if you're going to write a code, then use how are you going to write a code? So you're going to declare a variable called sum, right? So that variable is called integer sum. Okay, and then you're going to initialize to 0 first. So if you're going to write a code, it's something like that, right? So you initialize to 0 first. Whenever you do sum, okay, initialize sum to 0. Okay, so that is just tip. So whenever you do sum to additions, just initialize to 0. If you want to do multiplication, then initialize to 1. Okay, and if you're trying to find a minimum or maximum, then initialize to the first number. So I'm going to give you more on that. So for this example, we're going to do the count. Okay, do the sum. So initialize to 0. So essentially, what you need to do is you just need to use this, this final sum. Add 1 first, and then add 2, and add 3. So basically, you're going to do what? Sum equals the sum plus first one. That's the first one. And add this number to the sum. And then you do sum equals to sum plus 2, right? You add a second number to it. And then you do sum equals to sum plus 3. So then you add a third number. So you continue to write this how many times? 50,000 times. And eventually you're going to get the total sum. Okay? So the last one should be what? Sum equals to sum plus 50,000. So you're going to write 50,000 lines of code like this. Okay, so that is not fun, right? So let's try to do that inside use loop. So what we do with loop is this. So we're going to do for, okay, before the variable, before this loop, you already have this initialized. You already have this sum, the result variable initialized. And then you do, so every time you just need to just anything, and the only thing that changes is this number, the 1, 2, 3. Those can be considered as like steps, right? So I will declare a step count. So this time let's say step, let's just use j, okay? J equal to 0 first. So this variable does not have to be I, you can have any other number, have other names, okay? That's j equal to 0, and the j is less than equal to, the last number is going to be 50,000, okay? Semicolon. And this time we have to do j plus plus, because we are going to increase by 1 every time. And then inside the code, inside the curly brackets, the code is just simple, just say sum equals to sum plus j. And that is one line code to replace this 50,000 lines of code. Okay? All right, so yeah.
Why do you not put a semicolon after the j++?
Oh, that is a good question, because we actually, this is a syntax. So basically, this for loop just have like three parts. That's the first initialization step. This is a final check step, and this is incremental step. But there's no semicolon after this one. Okay, so don't. It's a very good question. No, you see, so this is just a syntax. There's no reason. There's no reason for that. So if you consider this is just like a three statements, there's not 3 statements actually. This is the first one you consider a statement, but the second one is actually not an independent statement. This is just the condition. This is just a j less than 5. So this second line is not really, second part is not like a command. But last one is a command. Last one is a command, but there's no semicolon with it. Okay. Good question. All right, so now let's go back to Visual Studio, and I'm going to create a button to do this calculation and show the number, show the result inside a text box. Okay. So let's go back to that. And then let's say we already have that forms. Okay, we have the form, but the enter leave. I'm going to use the same text box to show that count. Okay, so just say count to 100, right? So I'm going to just create a button, yeah? Button and sum to 100, okay? So here I'm going to just put text as 1 plus 2 plus ... 50,000, something like that. 50,000. Okay, so that is just a text. Okay, the text. And then give a name. Of course, name cannot have a plus, those kind of things inside. So we have to just use formal variable names, a button, sum. Okay? Sum. All right. And then after the button is calculated, and then once I want the result to be shown in here, in this count, in this variable, in this text box. Okay. All right, let's get started. Double click on this button. Okay, so first we need to declare a variable to hold. Declare a variable to hold the final result, which is integer sum. Okay, sum. And then we will initialize that also. So sum equal to 0. Next. Okay, and then essentially we are going to use 50,000 lines of code. Sum equals to sum plus something, right? So instead of that, I'm going to use a for loop. Okay, so for loop, integer j equal to 0, semicolon, and then j less than equal to How many? 5,000, right? No, actually, these kinds actually we start with 1. So 5,000, 50,000, 5,000. Okay, 50,000. So there are 4 zeros here. So this actually 1. So we have to start with 1, not just 0, because we're not doing actually the rate here. Okay. And finally, we do increment. So j plus plus. So you understand that that's just same as j equals to j plus 1. So every step, the count increase by 1. And then sum and then parentheses. And now remember to follow the code, follow the style. Okay. So you're going to have curly brackets aligned with a for loop, and inside the for, you see you're going to have 3 parts. Remember that there's nothing, no way around that. You have to remember where you have to practice. You have to remember. It's just kind of like a forming that as like a habit. Okay. And then you're going to do sum equals to whatever existing sum plus I. Semicolon. Oh, I. J. Sorry, J. Not I. We do not have I. This is J. Okay. So inside the loop, you can use J. The J is more like a local variable. There's a step variable. J equals to 1. And inside that, but outside, so for example, here, you cannot reference to J anymore because J is not, for example, J equals, if you do J plus plus, that will not work. Okay. Why? Because J is out of scope. This J is only valid inside this loop. The J variable is only like step variable, only inside this loop. Outside of the loop, it's not working anymore. So this loop is not, so the variable is not declared. So this is not going to work. Okay. Does everybody understand? So J, so that's basically, so variable is declared inside for the loop, then just valid for the loop. Variable declared inside this function, the button, then this variable is only valid inside the loop, inside this button, cannot be outside the button. Okay. Now, after this sum will be calculated, and then we are ready to report the result. So txt count that text equals to sum. All right, and of course, you need to do conversion. So let's say convert to string, right? Left-hand side is text, so string, and then sum. Okay. All right. And so this we are adding from 1 to 50,000. But if you want to change it to 10,000, to 100,000, or to 1 million, it doesn't matter. You can only change, the only thing you need to change is this number, right? So you do not need to write more lines of code because this loop will control how this code will be expanded. So basically, this loop will tell the compiler, this 1-line code will be expanded 50,000 times. So instead of you writing each line individually, the compiler is going to do it programmatically for you. That's what happens, okay? So you want to try what happens? So the addition should be a piece of a cake. Okay, so that's 1. Okay, of course, you're going to get the same result anytime. So if you're going to change to some other numbers, then this number will be changed very.
Professor, do you want us to submit this?